Welcome students to the video dealing with modulus function, also called the absolute value function. And let us look at what an absolute value exactly means before going into the functional aspect. Now, uh, so what is an absolute value of -3? Of course, you write it like this. For that, let us look at the a real number line. That is, of course, you have the midpoint. This goes to the negative uh, direction of infinity and the positive direction. Now, of course, it's very simple. -3 would be coming here. So what's the distance between 0 and -3? You'd easily say that it's -3, but what is the actual distance? Now, well, I mean, if you look at the without the signs, you can see that the actual distance between these 2 points, 0 and -3, is just 3. I mean, in the sense that you are just moving 3 units from 0, and if you look at that particular aspect, you can see that the sign of minus, or you don't have to put the minus sign on 3. So that's the meaning of it. So it simply means that the absolute value of -3 is actually 3. So that's the case with the what about I mean 1 so -1.2. That's again that would be 1.2, because that's the actual distance from 0. Of course, when you are looking at the positive side, of course the signage is not necessary. So it simply means that if you are for 3, naturally it would be 3. So you can see that when you introduce the absolute value, the result would be always positive integers, in the sense that you won't be getting a negative sign. And that's the key aspect of the modulus function. So how do you represent it? The modulus function is represented as f of x, and you have the output is the modulus, or the absolute value of the input, that is. So, and the input is x when x is greater than or equal to 0, and naturally it would be -x when x is less than 0. But as I already told, the key point is that you'll be getting the output will always be non-negative real numbers. So it means that the domain is equal to the set of all real numbers, and naturally the range should be the set of all non-negative real numbers. So it simply means that so what of f of 3 will be getting 3. That is the absolute value of 3 is 3 itself. That is, absolute value of 3 is 3 itself. And out of f of -3, and as I already told you, the absolute value of -3, we are looking at the actual distance. So it simply means that the signage is not necessary. It again would be 3. So you can see that the input values are differing in the sign notation, but as far as output values are concerned, we are getting positive real numbers. So it simply means that when you graph it, uh, you'd be dealing with the positive side of the y-axis. That is, so if the input value is 3, naturally, if this 3, then naturally it will be 3. And if the input value is negative 3, once again the result would be 3. So you can see that for 2, uh, it would be 2. And like once again for -2, again it would be 6. So you can see that you're getting a very interesting graph that is so. Now it's a graph uh, which divides both the quadrants into equal halves, and both the first and second quadrants into equal halves. And so that would be the graph you would be getting, and so this is a graph of the model of the modulus function, or the absolute value function. That is the function given by f of x is equal to the absolute value of x. And you can see that in both the cases, I mean, if the input is if the input is negative value, you are getting a y here and y also on the other side, which simply means that the output value is the same, and the input value is differing in the sign notation only. So that's a key point.